Welcome everyone. So today we're going to be talking about improving the overall picking process for Emerson Automation Solutions. Today we have Rania, me, Gavin, Tim, Nick, Vincent, and Parker, just to kind of go over the nuances with this process and how we kind of started to make improvements in those areas and identify the major problems. So if we move forward from there, within the phase one of the project, we basically just wanted to take a couple of steps to understand what exactly is the project, like where the process is and what exactly the problem is, so we can kind of start to address it and go from there. So just to kind of start off with, as shown in like figure one, the diagram that we have listed here is just a rough overview of the overall process. So we kind of sketch it out with like the value stream being kind of the pulling of valve materials for production. And then we kind of establish the trigger is like a picker will fill out the work order log. And then the overall process includes pulling, verifying, and staging within the picking process. And then following all of that, we found that it was very critical for employees to kind of be following certain regulations when it comes to safety and cleaning up following the fact. And then the final stage of that process is to deliver those items to assembly so they can build the product itself. So in doing this, we also developed a scope diagram. This basically kind of attributes like the entirety of the process itself, so we can kind of identify what's in scope and how, like, what things to kind of address moving forward. So it kind of talks a lot about a little bit about the context surrounding that process, and just as a couple of examples for like the pulling valve materials process as a whole, we kind of attributed the different inputs that existed within this, which would be like the work order, which is then delivered to a picker, so on and so forth. Enablers, which kind of reference like the resources that support the process, even though they're not being directly consumed. Some examples that we had of that were inventory management, employee training, things of that sort. Controls kind of involve mechanisms that ensure that the process stays in track. So that's like quality assurance and performance monitoring, just to make sure that everything within the process is kind of kept up to par and is up to kind of the standard that's set for the company. And finally, the outputs to those things would be like the parts order and then updated inventory, which is then sent to the assembler and then reflected in the varying systems associated with it. So from the scope diagram, as we kind of talked about the different aspects of it with the inputs, outputs, enablers, controllers, etc., we kind of looked at the specific problems that exist with both of these. So the entire point of this was to kind of develop a broader understanding of what problems exist within this process, so we can kind of select some major ones later on down the line, and then kind of make adjustments to the process to kind of solve for the problems that exist. Some examples with the different identified problems kind of include like parts being disorganized and placed in unpredictable locations, which therefore kind of impacts the efficiency of the overall process. Work orders are completed but then delivered to assemblers, but sometimes the work orders aren't fully completed, and then that causes delays from there. Kind of means that details have to travel back upstream. We also discussed like pickers not having proper training, which also results in a couple of different issues. And then when those pickers are grabbing items, there isn't really a standard procedure. And we kind of identified all of those things as either medium or high level like impact problems, which then kind of influence our decision to select two out of those groups and then, try to focus on solving those from there. And then just in our kind of overall like reflection of the process itself, we took a look at the process that we were kind of like mainly trying to work on, and we developed this kind of straightforward diagram of all of it, and this kind of built into a more in-depth diagram later on so we can display like more minute and intentional changes. But ultimately this kind of reflects what we were discussing here today, which is like the work order is created, a picker gets assigned, they grab items, so on and so forth, and then ultimately it's delivered to assembly, and that's kind of where the process finishes.
For phase two, we'll be looking at the process modeling, where the processes and where the problems lie. These will include things like the high impact problems as well as improbable analysis. Beginning with the process analysis, Emerson Automation Solution faces two major issues in their pull valve material process. The first being disorganized rack storage, where inefficiencies in inventory organization leads to slower order fulfillment and higher error rates, affecting capacity and process consistency. The second is the material accuracy issues. These discrepancies in materials and quantities disrupt workflow efficiency and reduce production analysis. Overall, both problems stem from inefficient handoffs and human errors in key sub-processes like the inventory organization and forklift operations. For the as-is process diagram for the pull valve materials problem, after examining the process further, we gathered information from Emerson employees directly at the factory within each department to grasp a better understanding of the picking process. Each activity within the workflow diagram was discussed by management to find the cause of each problem. And if you look at the diagram here, it starts with the received customer order, moves to order required material, create work order, and then the first problem for the high impact problem we identified was the organized inventory. And then moving on to the second high impact problem of the forklift pull material, delivered to assembly, and then the end of the process.
Here is that organized inventory sub-process that was mentioned earlier. And this is for our first high impact problem of the organized inventory. And it involves receiving and putting away new inventory. The stop sign is indicating next to the activity of is there a location number, which shows that there is a labeling is a problem and that it needs to be improved because items are not where they say they are in the system. And pickers have identified challenges related to the disorganized state of storage racks where products are placed in suboptimal locations. This disorganization not only prolongs order fulfillment times, but also increases the likelihood of errors in order picking. Moving on to the first high impact problem of inefficient rack organization, and bottlenecks is one of the problems with that. So the challenges we face in inventory management are that pickers often encounter delays because the system's inventory records don't match the actual stock on the shelves. Sometimes items marked as in stock are entirely missing. Additionally, when new stock is restocked, it often isn't placed in the correct location, leading to inefficiencies. And the barcode scanning system, which could help mitigate these issues, is underutilized due to its own technical challenges. Moving to forklift usage, a lack of available forklifts creates downtime, and when pickers can't access parts, they have to wait for a forklift to become free, which slows down production. Compounding this issue is the limited supply of forklifts due to supplier constraints. Now moving on to variation. In this process, variation in inventory management primarily stems from the inconsistent placement of new stock. For example, the same part might end up in multiple locations because there is no assigned home locations for items. While this is not ideal, sometimes it's unavoidable due to high customizability of our business model, which requires handling a wide variety of specialty parts. And reducing variation, we can take a few steps to reduce unnecessary variation. We can assign home locations to frequently ordered parts. This will simplify restocking and improve the organization. And we can also implement automated location assignment systems to standardize placement, but keep in mind safety concerns for large and heavy items. Now moving on to the second sub-process.
This is our second high impact problem diagram, or for forklift pull sub-process. This diagram displays the outcome of mispicks, and the red stop sign depicted in the assembly lane does not results in there being a delay up to 30 minutes to an hour. But as you can see, the delay is moving it backwards, which has us go through the whole process again. Process controls is our first high impact problem we came across. The process controls are broken up into two categories, the first being existing controls. These would be such as the OSHA requirements for all employees to be forklift certified for their own safety, but the safety of others, things that may also be out of control of the companies to change. The second being people in training. The papers for parts to be pulled for valves are disorganized and hard to read, causing time to be wasted to decipher the papers and correctly pull the materials. Also, how newly hired pickers are received training through shadowing instead of designed processes. The inconsistency that people receive through shadowing may lead to delays and mispicks when they are to pull materials. This lack of a standard training protocol and retraining courses leads to the building of bad habits that may lead to issues. The second high impact problem we came across is human involvement. There are a lot of variables in the process for pulling materials. This is a very complex process that requires precision and consistency. Attention to detail is a requirement to be able to do it efficiently. Another way to keep pickers knowing how they did is providing feedback on their performance. Having the assemblers tell them how they did, and if they made a mistake, is a valuable key to helping the process move smoothly. Instead, some assemblers will go out and pick the parts that are missing instead of finding a picker who missed them and letting them know. This can cause delays in several parts due to a lack of forklifts that we've already covered, as well as the knowledge that pickers have built up may betray them due to a lack of organization that we also covered earlier.
So now on to phase 3, our process redesign. What is our solution? This phase focuses on addressing the challenges in the pull valve materials process with targeted solutions to improve its efficiency and its accuracy. So to begin, here's our redesign plan for the pull valves material process. We targeted issues like disorganized rack material discrepancies with these solutions. For example, we have the plan of enhanced trainings to train pickers and link employee numbers to the SAP for error tracking, and also offer targeted training and adjust product placement to minimize those mispicks. As well, we have a buddy check system, which is a double check system for material quantities before delivery to assembly to improve its accuracy. And finally, an improved organization to use precise box labeling and implement recycling system to manage the clutter, maintain the cleanliness, and streamline the operation. Next, here are the most important. So we have a design principles checklist, and here are our most important design principles that guided our redesign. Number one is that we focused on designing from the outside in. So we have DP number 7, which is continuous flow, for example, enhanced picker training to maintain a steady workflow and reduce mistakes. DPD number 3, which is minimize handoffs and improve collaboration by assigning pickers a specific supervisor for guidance. DP number 15, which is a buddy check system, like I said earlier, where co-located teams verify material quantities and resolve issues in real time. And then DPD number 2, for example, is introducing a new labeling and recycling system to create an organized and efficient workspace. So here's how we redesigned the forklift inventory and organized inventory sub-process. So we focused on faster turnaround by streamlining supplier interactions and reducing lead times. We also wanted to reduce unnecessary handoffs between departments, consolidating responsibility and improving efficiency. And then we also worked on adjusting the workflows to ensure tasks are handled by those with specialized knowledge to reduce errors. We created a centralized project coordinator role to streamline the communication and limited idle time between steps with automated alerts and smoother handoffs, all inside of our inventory sub-process. Thank you for our attention to our presentation. We appreciate it. Thank you.